Okay. So before we go to the next chapter, that is our uniform flow, I want to discuss with you about our momentum equation. Okay. So we all know what is momentum. Momentum is nothing but mass into velocity. So basically, your momentum equation is based on Newton's second law of motion. Okay, it's based on Newton's second law of motion. That is summation of all the forces considering in the direction of flow is equal to rate of change of momentum in the same direction. Okay, summation of all the forces considering in the direction of flow is equal to rate of change of momentum in the same direction. That is, same direction means that is the direction of flow. Okay. For derivation, you can see this figure 1.15. Okay, definitely this is an open channel. We have considered two sections. One is 1, one is 2. Okay, definitely it is in higher elevation. We can consider it is an upstream, and we can consider it is an downstream. Okay, with lower elevation. And we all know the water is flowing from higher elevation to the lower. So this is the direction of flow. Okay, this is the direction of flow. Okay, so in that section 1, if we consider pressure, we consider it as P1. Okay, pressure at section 1. Okay, similarly for pressure at section 2, we consider P2. Okay, this is our bed of the channel. Okay, as definitely we should have some slope because it is in higher elevation and it is a lower elevation. So if we consider a datum line, or you can say reference line, okay, so this W will be perpendicular to this reference line, or you can say datum line. Okay, so this W is perpendicular to this datum or reference line. This is a straight line. Okay, so we have to, so if this is your perpendicular, then it will make some angle with your bed of the channel. As this is your not straight, or these two line is not parallel, your bed of the channel and your datum line is not parallel, so it will make some angle. Okay, and this theta is nothing but your slope. Okay, slope of the channel, or you can say bed slope of the channel. Okay, then we all know we have to resolve into two component. So one is W sin theta, one is W cos theta. W is nothing but the weight of water inside, or you can say in between section 1 and 2. Okay, weight of water in between section 1 and 2. Okay, that is your W. Okay, so here pressure for section 1 is P1, pressure for section 2 is P2. These two pressure is hydrostatic. Okay, so these things we are going to discuss later on in details. Okay, so for velocity for section 1 is V1. Okay, and velocity for section 2 is V2. Okay, this is your discharge, and definitely at the bottom of the channel we have friction. Okay, if the water is flowing from upstream to downstream, then our friction force is always in the opposite direction. So it going to resist the flow. Okay, so that is why our friction is in opposite direction. This is the flow of water in this direction from upstream to downstream, and our friction is in opposite direction. So now we are going to use Newton's second law of motion. Okay? Newton's second law of motion to derive momentum equation. Okay. So what is Newton's second law of motion? Summation of all the forces in the direction of flow is equal to rate of change of momentum. Okay. So first we are considering in a direction of flow. Okay. So first summation of all the forces in the direction of momentum. Sorry, in the direction of flow. So first is P1. It is in this direction. Our flow direction is this, and P1 is in the same direction. That is why we have taken positive. Okay. Next, if you consider pressure at section 2, it is in opposite direction. That is why we'll be having negative. P2. Okay. Then addition. Okay. Then the weight we have resolved into two direction. One is x and one is y. So definitely W cos theta is not in the direction of flow. Okay. It is in a downward. So that's why the W cos theta we are not going to consider. Okay. What we are going to consider is W sin theta as it is in the direction of flow. So this will be again positive because the direction of flow and the direction of W sin theta is same. So it will be W sin theta. Okay. Next, next is another one term we have friction factor. Okay. So it will be negative. Definitely it will be in opposite because friction is a resistance force. So minus F by F. Okay. That is friction force. Okay. So this is the summation of all the forces in the direction of flow is equal to rate of change of momentum. Okay. So change of momentum, we know mass into velocity. So we can write mass, or you can also write initial momentum minus final momentum. Okay. It's up to you. You can write initial momentum minus final momentum. Okay. As we are saying rate of change of momentum, then it will be divided by time. Okay. Change of momentum, that is initial momentum minus final momentum, and when we are saying that it is rate of change, so it will be divided by time. Okay. So momentum is nothing but mass into velocity. So we'll take mass common. Velocity we can take v2 minus v1. Okay. Okay. So here also mass into velocity. In final momentum also mass into velocity. So our mass will be constant. So we have to bring it out. Okay. It will be v2 minus v1 divided by time. Okay. Divided by time. Okay. Then density equal to mass by volume. Okay. Density is nothing but mass by volume. So mass equal to, we consider mass equal to density multiplied by volume. Okay. So in place of mass, we are going to write density into volume. Okay. Density into volume. Okay. and then we have V2 minus V1 divided by time. Okay, divided by here we have mass into V2 minus V1 divided by time. So in place of mass, we have substitute density into volume. Okay, as we know, density equal to mass by volume. So mass will be density into volume. Density multiplied by volume. Then what is the unit of volume? Is meter cube. Okay, and then we have time. Okay, so divided by second. So this is nothing but our discharge cube. Okay, we say meter cube per second is nothing but our discharge. Okay, so what we are going to do, we are going to substitute that volume divided by time. We are going to substitute as discharge. Okay, this part we are going to substitute as discharge. Rho into Q multiplied by V2 minus V1. Okay, okay. So what will be the final expression? That is P1 minus P2 addition W sin theta. Okay, minus then there will be friction as it is in an opposite direction. That's why we have used negative. Okay, then density multiplied by discharge multiplied by V2 minus V1. Okay. See, you have to, if you want, you can keep this equation till here. Okay, but if you see here, it is given specific weight by gravity. Okay, so this is nothing but we are going to multiply it by acceleration due to gravity in numerator and denominator. Okay, we have multiplied by acceleration due to gravity in numerator and denominator. Then this will become the right hand side part. Rho into J is nothing but your specific weight divided by acceleration due to gravity multiplied by Q, that is discharge. Then at last you have E2 minus V1. Okay. So this is your momentum equation. Sin theta minus friction factor is equal to specific weight divided by gravity multiplied by discharge multiplied by change in velocity. Okay, so this is your momentum equation. If you have any doubt, you can ask me now. Okay, regarding this derivation. Uniform discussed. Okay, if we have a channel, this is the level of water. Okay. Uniform flow we have already discussed. Okay. If we have a channel, this is the level of water, and we have considered two sections. Okay, one is upstream, one is downstream. Okay, first section, second section. Okay, so what we are going to do in first section, we measure discharge, velocity, and depth of flow. Okay, discharge, velocity, and depth of flow at section 1. Then we travel some distance. Okay, travel some distance x meter, and then we take another section and we are going to measure the same parameters, that is our discharge, velocity, and depth of flow. If all the three parameters are same in both the section 1 and 2, then we can say the flow in that particular section is uniform flow. Okay, then we can say a flow in this particular channel is uniform flow. The expression you can write change in discharge with respect to change in distance is equal to 0. Okay, or next you write change in velocity with respect to space is equal to 0. That means we don't have any difference in velocity. Okay, that velocity we have measured in section 1 and section 2 is same. And third is change in depth with respect to del x is equal to 0. Okay, these are the three expression you can write in case of uniform flow. You can see here are the three expression: velocity, discharge, and depth of flow. Okay, you can see here. Okay, so this is our reference or datum line, is a straight line, and this is bed of the channel. Okay, we have considered two section 1 and 2. Section 1 is in higher elevation and section 2 is in lower elevation. So water will be flowing from higher to lower elevation. Okay, so that velocity we have measured for section 1 is v1. Discharge we have measured for section 1 is q1, and these things we have already studied, that is your total energy. Okay, total energy, gy. Okay, energy. So this is kinetic energy head, that potential head, and then we have datum head. Okay, so that is in section 1. So that is why v1 square by 2g, y1, and z1. Okay, the total energy, if you add all the three, we will get total energy for section 1. Okay, and if you see when the water flows from the higher elevation, or you can say section 1 to section 2, during that process there is a loss. Okay, head loss due to friction, because whatever the velocity we are getting here, definitely this velocity may vary because of this friction. Okay, so there is a loss, that is called head loss due to friction. Okay, if you want to say that total energy for section 1 and section 2, then for section 1 you have to find total energy, and for section 2 you have to find total energy, then you have to add this loss. Okay, then only we can say the total energy in both the section is same. Okay, you can see here we are using Bernoulli's equation to find out the total energy. So we have datum head at section 1, potential energy head at section 1, kinetic energy head of section 1, okay, is equal to datum head at section 2 plus potential head at section 2, kinetic energy head at section 2 plus we have to consider the loss, okay, then only your total energy total energy total energy at section 2 and total energy at section 1 will be same, okay. Total energy at section 1 is equal to total energy of section 2, okay, if we consider the loss, okay. One important thing in uniform flow, our bed slope, friction slope and surface water slope will be same. All slopes are same for uniform flow. Uniform flow. Okay? For uniform flow, all these slopes are same. Then we consider momentum equation. These things we have just now we have discussed. Momentum equation. Then if our depth of flow, as we know in our uniform flow, our y1 is equal to y2. If we consider uniform flow, so that is why the pressure related to the depth, okay. So that is why P1 and P2 will be same in case of uniform flow, okay. So these two will be cancel out, okay. Then velocity is also same if we consider uniform flow. So this also be cancel out, okay. You can see here V2 equal to V1 and P1 equal to P2, okay. So what will be left out? From here it will be left out as W sine theta minus friction factor is equal to 0. Minus friction factor is equal to 0. Okay. So as this is 0, V2 minus V1, if it is same, it will be 0. Then 0 multiplied by this, again it will be 0. So that's why in right hand side, it will be having 0. Left hand side, this will be cancelled out. What will be left out is W sine theta minus friction factor. Or you can also say that W sine theta is equal to friction factor for uniform flow. See, this equation is your applicable to any case of your open channel flow. Okay, is a uniform or non-uniform. So this is only for uniform flow. That W sine theta is equal to friction factor. Okay. So next topic is your average velocity. Okay. Yeah, theoretically we can calculate velocity by two equations. Okay. One is your Sages and one is your Manning's equation. Okay. One is your Sages equation and one is your Manning's equation. I think you have already studied about these two equations. Manning's equation, they most commonly use this Manning's equation. That is your 1 by n. N is nothing but your roughness coefficient. R to the power 2 by 3. SB to the power half. SB is nothing but your bed slope. Okay. SB nothing but your bed slope. R is your hydraulic radius. R is your area by weighted perimeter. Okay. Area by weighted perimeter. Okay. And N is your roughness coefficient. Whereas for sages is C multiplied by root over R into SB. Okay. C is your sages constant. Okay. R is nothing but your hydraulic radius, that is area by weighted perimeter, and SB is nothing but your bed slope. Okay. Okay. So you can note it down, the relationship between your C and N. Okay. Says constant and Manning's equation. When you go for competitive exam, you can find this question. Okay. Relation between says constant and Manning's N. The derivation is not in your syllabus, so we are not going to discuss, but you can note it down, the expression. That is C equal to 1 by n r to the power 1 by 6 is equal to root over hg divided by f. Okay. This expression or relation, you can note it down. Okay. Next topic is our economic channel section. So this topic you have already studied in third semester, so we are not going to discuss in details. Okay. So here in third semester you have studied about derivation of economic section. So here derivation is not required, only the condition we require. What is the economic condition for rectangular channel, trapezoidal channel and circular channel? Okay. So here you study about rectangular channel. Okay, you have to study of your own. Rectangular channel. Number two, trapezoidal. Trapezoidal. And number three is circular. Okay. Okay. So these things you have already studied in third semester. So we are not going to study here again. Okay. But we are going to use that condition or expression for rectangular channel, trapezoidal and circular in the numericals. So this part, this part is self-study. Okay. The study of your own. You can follow your third semester notes, or you can directly follow that book also, RK Bansal, hydraulic and hydraulic machine. Okay. This is your self study. Okay. Okay, so here Manning's formula is not visible properly. This is nothing but your Manning's formula, 1 by n r to the power 2 by 3 sb to the power half. Okay, this is nothing but your Manning's formula. Okay, and Sage's equation.
All are requested to give your attendance in the chat box. Okay, write your enrollment ID.
Okay, so we will continue this class in 10-15 minutes. Okay, or we will start the next class. Okay,
So this meeting is about to end. Okay, so kindly join again with the same link. But first, you give your attendance. Okay, for this class. What about the rest? Kindly give your attendance. Okay, fine. Okay, join again with the same link. Okay, thank you.